Hello everyone, my name is Ben Hickey. I'm co-founder and chief customer officer here at Lumina Networks. And so my team works on sales, product management and our NetDev Services, professional services arm. So today I'm going to talk to you a little bit about multi-access edge compute, or MEC for short, and network slicing, two very important 5G telecoms infrastructure rollout projects. And in particular, I'm going to talk about Lumina's SD Core solution and how that can enable these MEC and network slicing initiatives to be rolled out far more quickly and cost effectively than you might otherwise think. So if we think about service providers today, they have got a very good deployment of network infrastructure based on high quality, highly available, typically MPLS technology. And that same MPLS technology is deployed across two real domains. And so we can think about it across the core domain, and for the purposes of our conversation today, we're just going to leave that as a cloud. And then we can think about it across the MPLS deployed across the backhaul domain. And typically a backhaul domain here will be a set of routers, and these routers are deployed could be a hub and spoke physical topology like this, or it could be in a ring topology, but for the purposes of our conversation today, that doesn't really matter. And so these routers and PEs will then be providing services, and they're already in place for a whole bunch of different users, enterprise customers, but also these new MEC, if you like, edge compute pods, which are being deployed by carriers in a fairly big way to service their 5G needs. And this will allow virtual functions to be moved not just from centralized data center locations to edge locations to support needs, whether it's services, service quality like latency and things like that. It could be to support things like scaling, moving functions closer to the edge so they can scale to in a smaller zone to the higher levels, or it could be for specialist kind of applications, some of which we might not even know. But as these MEC pods are being deployed, they're being connected back into these existing infrastructures. Now these infrastructures today will have running over them network services. And this kind of MEC infrastructure will typically be plugged back into a VPLS instance or a pseudowire, could even be an IPVPN. And these services, there'll be many, many, many of them. And so you could have anything from 100 of these up to 1,000 or more. And all of those services will directly be running over a common set of LSPs, or what are called label switch path. And in the MPLS network, all of these services will actually share a common LSP. And so at the LSP level, we don't actually see which service is which service. We might see some individual packets can be classified as more important than others, but we've got no service visibility. So they're all in effect sharing the same quality of service metrics across the physical network. And that's how things are pretty much run today, and that's how many people are actually thinking about rolling out MEC and trying to do that quickly and cost effectively at this stage. But if we actually think, how could we actually leverage other trends which are underway? And if we think about software, in particular disaggregated software stacks leveraging open source, we have the opportunity with an SDN controller, which could be deployed here with a PCE engine running on top of it. And this is actually what Lumina calls our SD Core solution. So we've got our SDNC here, and this SDNC can actually be plugged into the existing infrastructure and can use existing protocols like BGP LS and PSEP. And because our SDN controller is based upon open source, so out of the box, it's been designed to work with multi-vendors and multi-technologies. So it's very easy for us to actually leverage this over your existing infrastructure, no matter what the vendor, what the software version is, leveraging these existing protocols and the flexibility inherent in the open source code. Now, by adding this in, we're actually able to overcome one of the major issues that has kept this MPLS infrastructure pretty much the same way since it's been deployed over the last 15 to 20 years. And so the reason why we've got this simple infrastructure, simple model here of having lots of services mapping to one set of LSPs is really around operational complexity. So if we were to configure many, many more LSPs with different service types, it becomes very hard for a service provider operational group to manage that. And if it becomes hard, there's concerns about reliability. And so that will stop people from doing it. But by using software-based techniques where we can encode all of these different services and LSPs effectively in code, that allows us to leverage software testing techniques to make it much more reliable and therefore leverage a more sophisticated service model on top of our existing infrastructure. So what we really refer to here is these are latent capabilities available in our existing deployed networks, but they haven't been turned on because of operational complexity, and that now is no longer a problem as we overlay software. So if we imagine what that might look like, we could actually now leverage the SDNC and the PCE engine to deploy in real time new network services. And that could be, again, just like it was before, a VPLS or a pseudo-wire or a VPN. But that service is just the same here. And then what's different is we can deploy in real time a new LSP, which is mapped just to this one set of services. And this LSP could be a very specific topology. It might be for an autonomous vehicle set of applications, something that has local switching enabled all the way out to the MEC, or for another service, it might be very much hub and spoke, where it's just a direct backhaul to the centralized core infrastructure. But this is then set up in real time and deployed across the common infrastructure. So now at the MEC POG, we have our default or our pre-existing services sharing these common paths. That could be for our best effort or any of our default traffic. But we can now make available in real time this new service, which is carried over a different LSP, and so it can be treated at not just the packet level, but also the service level with differentiated services in this existing network. Now, because we're using open source and we're using this proven solution that's able to sit over existing infrastructure, that's really where we get the benefits I mentioned at the beginning around a much quicker deployment and a much more cost-effective deployment to enable this real-time network slicing in conjunction with our MEC deployment. So we have lots more information available on this and are able to provide demos and examples with different vendors in the network space. So if you have any more interest, please do contact us. But otherwise, thank you very much for today.